We are going to start talking about equivalent ratios, guys. So let's do this one together. It says Carrie and her friends are going hiking. Carrie invites her friends to meet her at her house for a quick breakfast before heading out on their hike. She wants to offer yogurt to her friends, and she knows one yogurt pack has 4 yogurts that can feed 4 people. Everybody got that? So it says, draw a model to answer each question and explain your reasoning. So I'm going to do A with you, and then I will let you do B and C. It says, what is the relationship between the yogurt packs and the number of people it will feed? So if I'm going to draw a model, what do I know about the yogurt packs?
Each yogurt pack has 4 yogurts, so it can be 4 people.
Each yogurt pack has 4 yogurts. Yes? 1, 2, 3, 4. And it can feed
4 people.
4 people. Yes? Does that make sense? Does my model make sense? One yogurt pack has 4 yogurts and it can feed 4 people. So I want you to draw diagrams and answer B and C for the same ratio, using the same yogurt packs and people. Make sense? All right, go for it. I'm giving you about 3 minutes. All right, today we are continuing with ratios. We have done part-to-part ratios, part-to-whole ratios. We've talked about quantitative and qualitative reasoning, and we've started putting them in real-world situations. And today we're going to continue with that and learn how to model our ratios. So the first thing I want you to do is the review at the bottom of the page. It says circle the correct statement to complete each sentence. It takes 5 workers to paint 3 houses in a day. You are using that ratio to answer questions 1 and 2. I'm giving you about a minute to get your answers circled, and then we will go over it. Done. 5. All you were doing was circling an answer, guys. Painting fewer houses with more workers will take less time, an equal amount of time, or more time. Who thinks it's less? Who thinks it's equal? Who thinks it's more? It is definitely less, but I'm concerned by how many people did not vote. It's okay. We're good. And painting more houses in a shorter amount of time requires fewer workers, an equal amount of workers, or more workers. Who thinks it's fewer? Pause. What? Just go to your desk. You're fine. Put that on mine. All right. Who thinks it's fewer? Who thinks it's the same? Who thinks it's more? It is definitely more. Good job. All right. Let's look at the next page. We are skipping 194 and moving on to 195 for time's sake. Guys, every time I tell you to turn the page does not require you to talk to your neighbor. Thank you. Carrie and her friends are going hiking. Carrie invites her friends to meet her at her house for a quick breakfast before heading out on their hike. She wants to offer yogurt to her friends. She knows that one yogurt pack has 4 yogurts that can feed 4 people. Make sense? So it says, draw a model to answer each question. What is the relationship between the yogurt pack and the number of people it will feed? So notice it says draw a model. So what do we know from our problem? We know that one yogurt pack, that's one pack, yes, has 4 yogurts, yes, and it can feed 4 people. Does my model represent what they told me in the problem? Yes. Make sense? Good, because I want you to use that same idea to answer B and C using the same ratio of 1 pack to 4 people. Any questions? Go for it. I'm going to give you about 3, maybe 4 minutes. Make sure you are drawing a model for both. Okay, if Carrie invites 5 friends, how many yogurt packs will she need? And it says to draw a model. So I start with my 1 yogurt pack that has how many yogurts in it? 4. 1, 2, 3, 1, 2, 3, 4. Yes? And how many people can that 1 yogurt pack feed? 4. Can I feed 5 people yet? No. I have to use the same ratio, so I need another yogurt pack. How many yogurts are in that? 4. 1, 2, 3, 4. And how many people can that feed? 8. Can I feed 5 people now? Yes. So how many yogurt packs will she need to buy? 2. It is a word problem. You need a word answer. And then it says, explain your reasoning. Yes? All right. If Carrie has 2 3/4 yogurt packs, how many friends can she feed? So I have 1 yogurt pack. 1, 2, 3, 4. 2 yogurt packs. 1, 2, 3, 4. 3 yogurt packs. 1, 2, 3. And Carrie got hungry on the way home from the grocery store, so she ate this one. It's no longer there. Okay? So, how many people can this yogurt pack feed? 4. How many people can this yogurt pack feed? 4. And now how many can this yogurt pack feed? 3. So how many people can she feed with 2 3/4 of a yogurt pack? 11. Make sense? Any questions about the diagram? No. You're just drawing what they tell you, guys. And it doesn't have to be perfect. All right, so another example is a variety yogurt pack that has 2 blueberries, 2 blueberry yogurts for 3 other flavored yogurts. Make sense? So it comes with 5 yogurts where 2 of them are blueberry and 3 of them are another flavor. And they drew it for us. Does everybody see that? Okay, so I'm going to do, actually no, I'm going to give you a few minutes to see if you can do just A. It says draw your model and explain your reasoning. How many yogurts are blueberry yogurts when there are a total of 25 yogurts? I want you to draw it out and see if you can come up with your answer. Just A. I'm giving you 2 minutes. Go for it. Okay, so it says how many are blueberry yogurts when there are a total of 25 yogurts? Well, what do we know? We know that there are 2 blueberry for every 3 other flavored yogurts. Yes? Yep. So do I have 25 total yogurts yet? No. So 2 blueberry for 3 other flavored yogurts. Do I have 25 yogurts yet? No. So 2 blueberry for 3 other flavored yogurts. Do I have 25 yet? So 2 blueberry for 3 other flavors. Do I have 25 yet? 2 blueberry for 3 other flavors. Do I have 25 yet? Yes. How many of them are blueberry? 10. That is what we are asking you to do. I want you to answer B and C, please. You have about 4 minutes. All right, B says, how many yogurts are blueberry yogurts when there are a total of 35 yogurts? So again, we're using the same initial ratio of 2 blueberry for every 3 other flavors. Yes? Do I have 35 yet? No, so I need to keep going. 2 blueberry for 3 other flavors. Do I have 35 yet? No, so I need to keep going. For 3 others. How many do I have so far? 15, so I'm not there yet. Now how many? Now how many? Just 5? Now how many? Now how many? Yay, we're finally there. How many of them are blueberries? 14. Yes. Please stop talking. How many total yogurts are there when there are 8 yogurts that are blueberry? So how many total yogurts when there are 8 blueberries? So I'm just going to use the one I did up here. 1, 2, 3, 4, 5, 6, 7, 8, and I'm going to draw my line. How many total yogurts do I have on this side? 20 total yogurts. Got it? Okay, before we do the definition at the bottom, I want to go over the ones that you should already have on your vocabulary page. So please pay attention because I'm only saying them once. Number 1 should be additive reasoning. 2 should be multiplicative reasoning. Table 1, how about you pay attention? Yeah, I'm talking to you. Look at your vocabulary page. 3, both boxes should be ratio. Sorry, both lengths should be ratio. 4 should be percent. 5 is qualitative reasoning. 6 is quantitative reasoning. And now we are adding a new one to 7. So you need your highlighter. Equivalent ratios are ratios that represent the same part to part or part to whole ratio. So that is number 7. And I want to show you what that means. Who knows how to make an equivalent fraction? So Nyla, what do you do when you're making an equivalent fraction? That's okay. Who else knows how to make an equivalent fraction? Sally, what do you do to make an equivalent fraction? Okay, when you find that common denominator, what do you do? By the same number. You're multiplying the numerator and the denominator by the same number to create a new fraction, yes? So that is basically what we did for all of these ratios that we made. We started with 2 blueberry to 3 other flavors, yes? Then when we got to number 2, how many blueberries did we end up? How many? For number 8? 10? And how many other flavors? How many? 15. So what do I multiply 2 by to get to 10?
5.
And 3 times 5 is? So it is an equivalent ratio because we multiplied both numbers by the same number. It is the same thing as making an equivalent fraction. Does that make sense? Good. All right, let's look at the next page.
The next one we look at is another diagram type. It's called a tape diagram. I'll be honest, when I first was introduced to these 6 years ago, I was like, that's kind of stupid, but as I've gotten used to them, these are actually pretty cool. And they're actually really easy to make, too. So we're going to add a couple things. First off, yeah, there it is. Okay. Let's do another visual representation. We've got variety packs that have blueberry, pumpkin, and bran, but they're also in the ratio of always 3 blueberry to 2 pumpkin to 1 bran. So it's always going to be that same part. So the first part we're going to do is we're just going to get you back into writing the ratios. So we want you to write the ratio that expresses each relationship, identify each as a part-to-part or a part-to-whole ratio. So there's 2 parts. You need to write the ratio and then identify what type it is. So let's do a couple just to make sure everybody understands what we're doing. So we're going to do blueberry to total. Okay? So if I look at it, there are 3 blueberry to how many total muffins are in the packs. How'd you get that? Let's add them up. 3, 2, and 1 means that there are 6 total. Does that make sense? So what kind of a ratio is that? Part to whole. Make sense? Okay, let's get down to E. Here we have bran to pumpkin. If I look at my numbers, I have 1 bran to 2 pumpkin. Yes? What type of ratio would that be? Part to part. Does that make sense? Okay, so I'm going to let you guys do the other 4. You can see it's not real difficult. It doesn't really matter what format you use, but make sure you're labeling what the part of the ratio is that you're talking about. Okay? So we'll give you guys about 3 minutes to do those 4. Okay, now I'm just going to give the answers because there shouldn't be much difference on this other than potentially the way you wrote them. So pumpkin to total, I have 2 pumpkin. 2. 6 total. Which type of ratio is that one? Another part to whole. Bran to total. Bran was 1, sorry. 1 bran. 2, 6 total. That gives me another part to whole. Blueberry to pumpkin. Blueberry was 3 to 2. And that would be blueberry to pumpkin. Which would be a part to part. And we've got 3 to 1. And that would be blueberry to bran. Does a part to part. So basically what I tried to do in the answer there is give you several different ways we can write our ratios. Any of them are acceptable, but you need 2 parts, right, Ava? It's not just numbers, I also have what I'm comparing. Make sense? Yes. For which one? Oh. Do you put parts in total? Technically it's a part to whole. If you roll parts in total, I'm sure we can probably count it. Okay, we need our highlighter pen, marking pen. Folks, be ready. So here's another format that we have instead of having to draw out all those different boxes like Mr. Ken did in those earlier models. A tape diagram, I did that earlier too. Tape diagram illustrates number relationships by using rectangles to represent the ratio parts. So in a tape diagram, instead of having all of those different boxes, we just draw the one box for each one. So here's what it looks like. For example, the ratio we were just doing where we have 3 blueberry to 2 pumpkin to 1 bran, here's what the tape diagram would look like. Okay? So if this is my tape diagram, what does each small rectangle represent in the tape diagram? What do you guys think? Yeah? Like, on what? Good. You just one muffin, right? So blueberry had 3, so we colored them blue to help you realize what it is. But each one is 1 muffin. That means for blueberry you get 3 boxes. Make sense? For bran there were 2, so we did 2 boxes. Or pumpkin there were 2, we did 2 boxes. Bran as well, we did 1 box. So each box represents one part of the ratio, one, in this case, 1 muffin. I do want to add a note on your tape diagram. The tape diagram is always done in simplest form. So the first thing you're going to do is simplify your ratio, draw the tape diagram. We'll talk more about that one in a little bit, but we've done a lot of that already. It comes out of your 4 key numbers, 2 by 7. Make sure I get it in simplest form I can. Then I'll draw my tape diagram. Because like some of the earlier examples, do I want to do 25 boxes of blueberry and 20 boxes of whatever the other one was? No. I want to do the 5 or 4. Any questions on the tape diagram so far? Okay, let's talk about how to actually use our tape diagram. So these are a visual representation. Now let's say instead of a 6-pack, what if I bought an 18-pack of muffins? How many blueberry, pumpkin, and bran muffins will I purchase? So there's the question. There are 6 muffins represented in the tape diagram, yes? And I want 18 total muffins that are in the same ratio. So we're going to add another term to your sheet, on your vocab sheet. There's a little blank space right down here at the very bottom of the front. I want you to add this term in here because this is one, you're going to hear this term a lot. Every time we work with range tape diagrams, you're going to hear this. Good. And that term is the ratio constant.
Write that at the bottom, everyone.
Okay, the ratio constant is
Super important.
the number in each box of the tape diagram that keeps the ratio equivalent. The reason we're having you add this is because this is a math term that I made up.
It works. I love it.
6 years ago, when I first was introducing myself to tape diagrams, we kept having this number in the box that had no name. So I made a name for it that made sense to me, ratio constant. You know, I use it in our tape diagrams for ratios, and it's a constant. Once I find it, it never changes. And we'll show you guys that in a second.
I was in here with my friend, when Miss Caruana was in here.
Yep.
Yep. I was like, oh, that's awesome. Makes it so much easier.
It's a lot easier to talk about when it actually has a name.
Exactly.
So here's what we did. We looked at our tape diagram. I said, how many boxes are there? 6. But I need these 6 boxes to equal 18 boxes, right? So to figure that out, I take 18 divided by 6, I get a 3. Guess what that 3 is? 10. It's my ratio constant. So once I found it, now it goes inside every box. So I write a 3 inside every box. Once you find your ratio constant, Every box gets that number. But here's the beauty of it. Once I've, and let me just add a couple things in this. Number one, all of these problems, they're basically going to ask you to be able to find the ratio constant. They're going to give you the information to find it. You have to put it together to figure out how it goes together. We'll talk about that in a little bit. But once you find it, now everything is easy. Because I can now look and I said, okay, I have 3 boxes of 3 blueberry muffins, right? So how many blueberry muffins do I have? 3 plus 3 plus 3. So I now have 9 blueberry muffins. 3 plus 3 means I have 6. 3 means I have 3, and if I add those up, I get my total of 18. And that's the beauty of the ratio constant. If you do it properly, it's going to work out every single time. So is the ratio 9 to 6 to 3 equivalent to 3 to 2 to 1?
Yes.
Yes. Can I explain how I know? Yes, because if I multiply 3, 2, 1 by 3, I get 9, 6, 3. In other words, if I apply my ratio constant to 3, 2, 1, I get 9, 6, 3. Does that make sense for everyone? Okay, so now we're going to see how well you guys can do at going the other way. Finding my ratio constant. Again, they have to give you enough information to figure it out. You just got to figure out how they go together. So our first one, we're going to have a 36 pack of muffins. Using our same ratio constant. Tell me, how many blueberry, pumpkin, and bran will I receive? So there's our question. And the other one, I have 20 pumpkin muffins. How many total, there's my question, will I have in the pack? So use that information, see if you can figure out your ratio constant. Put the ratio constant in, and then you'll be able to get your answer. We'll give you guys about 3 minutes. Go ahead and go. Okay, guys, again, the whole key is they have to give you enough information to figure it out. They just need you to put it together. So on our first one, it said, let's say 36 pack. So am I looking at 3 boxes, 2 boxes, 1 box, or 6 boxes? 6, because it's all of them, right? So I take 36, and I divide by 6, and what do I get? 6. So that is my ratio constant. Once I have found my ratio constant, it literally goes in every box. That's what makes it a constant. Now I just put them together. 3 6s means there are 18, 2 means there's 12, 1 means there's 6. So, to answer my question, there are 18 blueberry, 12 pumpkin, and 6 bran muffins.
Understand now?
Guys, stop talking and pay attention.
Does that make sense to everybody? Is anyone who is still lost on that one? Okay, our next one, again, they give you the information, but you've got to apply it. So it says there are 20 pumpkins. So I know that my pumpkin is 20, right? How many boxes are there? 2. So what does each box get for my ratio constant? 10. Once I have found it for any one box in my tape diagram, every box gets that ratio constant. Meaning there are now 30 blueberry, 10 bran. Well, what was my question? Total. So what's my total?
60.
There are 60 total muffins. Everybody see how these pieces go together? Okay, again, they have to give you enough information to figure out your ratio constant. So look for whatever number they've given you. Look how that goes into your tape diagram. That is going to be what you divide by to figure out your ratio constant. For right now, it's all going to be even numbers. It should make it very easy for you. Questions, guys? Okay, let's go to our next page. So another way we can do it is using tables. Tables tend to get kind of big and messy, but they want us to show them to you, so we will. But in this one, they just want us to complete the missing cells for the 6-pack and the 36-pack. So given the fact that they basically base this off of our row of 18, that's what we need to start at to go to our other two numbers. So how would I go from 18 to 6? And I'll give you a hint. It's got to be multiply or divide. How do I go from 18 to 6? Divided by 3. So if I divide the 18 by 3, guess what I'm doing to all the rest of the numbers? Dividing by 3. So 9 divided by 3 gives me 3. 6 divided by 3 gives me 2. 3 divided by 3 gives me 1. So technically now at 36, I got two options. I can go all the way back to 6, or I could just go 18 to 36, right? How do I go 18 to 36? Times 2. So I can just go like this, times 2. So I'm going to double all these numbers, gives me 18, 12, and 6. So if I look at what we've now got for our completed columns, what do you notice about the numbers? Any patterns you guys see? Okay, so just to refresh for everybody what Alina just said, what she said, if I start at 6, I can multiply by 3 to get to there, then I can multiply by 2 to get to there. So do I have to do the same number every time? No. As long as I use the same number to all of them, that's the key, right? So as long as you multiply, and did we actually divide too? So as long as you multiply or divide, all columns by the same number, they stay equivalent. So two parts to that. One, it has to be multiplication or division. We can't be adding and subtracting. Second is, it has to be everything by the same number. So it doesn't matter which I do, a multiply or divide, as long as I do the same thing to everything. Does that make sense for everybody? So how could I determine the number of each type of muffin in the 18 pack without using a tape diagram? So in other words, they're saying they gave us this based on our tape diagram numbers. How could I have done that if I just started here? Alina? Multiplying them all by 3. So we could have taken the base pack, and multiplying everything by 3. So again, really the biggest key there, guys, as long as I do the same number, it doesn't matter what it is, it's going to stay equivalent. So the whole key in this entire operation is figuring out what that number is that we were using. So how can I determine the type on the 36 pack without using the tape diagram? Someone other than Alina. Thanks, sir. A little louder, I can't hear you. Could have just used a table. Okay, I'll put that down. We could have just used a table. Or, what did we end up doing? Multiplying them all by 2. Or actually, going back to our base, multiply our base by 6. So if you multiply every number in the base pack by 6, you'll still get to that end result. Now, here's where it gets going to get a little more challenging. We want you guys to go ahead and fill in the 12 and the 24. Now that you've got this information, make sure you show on your table how you did it. We'll give you guys about 3 minutes. Go ahead and see. So you have several options, but because they've taken it back to our base of 6, 3, 2, 1, that should make the rest of them really easy, guys. How do I go from 6 to 12? Multiply by 2. So guess what I'm doing to 3, 2, and 1? Multiplying by 2. The whole key on this, whatever I do, I have to do the same thing to every line. Now you got a couple choices. How would I get to 24? I can either go back to the 6, or I can go from the 12. 18 actually won't help me on that one. Anita?
I multiply 6 by 2. So I started by the 12. And multiply that by, I mean, 4.
So I'm actually with Alina. I'd go 12 times 2. You could have gone back and done 6 times 4 if you wanted to, but since I already got this, I'm just going to double the numbers. That's easier for me. It gives me 12, 8, and 4. Does that make sense? That's fine. Yeah, 12 times 2 gives me 44, right? So, whichever pattern you want to use works as long as you're consistent. So, did we explain our strategy? Yeah, we did. I put the work on my table, didn't I? I showed you I multiplied by 2, and then I multiplied that one by 2. That's the beauty of showing your work. That is a form of explanation, is it not? So, Roland, is it important to show your work? Very much so, because that's what helps Mr. Chan and I understand how you are thinking. Any questions on anything we covered on this page for today? Okay, so the good news is today's homework is just Mathia. Realize you need to be up to 34 total workspaces by next class. That is on Friday. So you should be at 34 by Friday, guys.
Nice.